Welcome everybody to Integrated Math 3. In today's episode, we are going to be beginning Chapter 11 with 11.1.1, which is Simplifying Rational Expressions. So let's go ahead and break down what we are talking about before we begin the chapter. A rational expression is simply a fraction. It's an expression that can be written as a fraction, and that's what we're going to learn how to do in this lesson today. We're going to learn how to simplify fractions, which we've done before. We've done a lot of it. If even before Integrated Math 1, if I gave to you something like 4 over 6 and asked to reduce this fraction, of course, hopefully people would know that that would be 2 over 3. The question is why does it suddenly become 2/3? What was the action that was taken that would allow us to simplify or reduce this fraction? Well, what happened here is when you look at the 4 and you look at the 6, you start noticing things that they might have in common, numbers that they might have in common. So if I looked at 4 in a bit of a different way, I could call him, instead of 4, I could call him 2 times 2. And then same thing with 6. I could call him, instead of 6, I could call him 2 times 3. And then back in Integrated 1, you guys learned this like giant number 1 right here, I think is what they called it. So I'll go and just draw that same thing here. Whoops, my block got a little messed up there. And the reason why they wanted that giant 1 emphasized is because that guy then reduces out, and the 2/3 is what is remaining, and that is why 4 over 6 equals 2/3. So let's go ahead and break down what happened in this problem. That way we have some steps to take care of future problems. The first thing we did was we separated our numerator and our denominator out, almost uncoupling the multiplication that was already there. There's a word that actually describes this uncoupling of multiplication, and you've done it a lot. In fact, it was one of the most important things you learned in Integrated 2. It was known as factoring. What you did is you factored the 4 into 2 times 2. And then the same thing with the 6. You factored the 6 into 2 times 3. Afterwards, we canceled. And then afterwards, from there, we brought over what was remaining. So bring over what is remaining. So it's a pretty simple idea here when it's straight up numbers, but let's see what happens when we have variables thrown into the mix, because obviously we have to get a little more difficult as we progress through the math. So if I was to suddenly say 2x minus 6 over x minus 3, and I asked us to simplify this expression, how could we go about doing this? Well, what I could do is I could look at the top and I could say, I see a GCF. We learned GCF back in Integrated 2, so I'm going to go ahead and employ said GCF here and pull out that 2 and give myself 2 parentheses x minus 3 over x minus 3. Obviously, I think we're starting to see our magic 1 show up here. And of course, these x minus 3's really will cancel each other. But before I do that, I do want to talk about this expression, this 2x minus 6 over x minus 3, and how it differs from the previous expression. How are they different? Well, for starters, the top one, the 4 over 6, I'll call them example number 1 here, the 4 over 6 is straight up numbers. It's a constant. It's a constant over a constant, and there is no possibility of anything bad happening when I reduce a constant over a constant. 2, on the other hand, has some issues. And that's because in example 2, there is an x involved, and x is a representative of a variable. A variable can be any number it wants to be, most of the time. In this example here, because we're dividing and there's an x on the bottom, there is going to definitely be a problem if x equals a particular number. Now, if you would like to, go ahead and pause the video and see if you can think about what number that is. What number plugged in for x would give this expression some trouble? Go ahead and pause, and I'll give you guys a second. What can't x equal? X can't equal 3. If you said that, good job. And that's because if you plug in a 3 into the bottom, you'll get 3 minus 3, right? You'll get 3 minus 3, and then that equals 0, and then you're dividing by 0, and that's bad. We learned in Integrated 1 that dividing by 0 is undefined, so you don't want to let x equal 3. This right here is what we call an excluded value. You'll see me refer to this as EV as we move forward, just so that we can abbreviate and shorten up our handwriting. So one of the things that is going to be added on to this three-step process here that we just identified in the rational expression is stating the excluded values. We're going to need to do that for every single one of these problems. So let's go ahead and do some examples. So if I was to do something like this, example 3 here. If I was to do 2m minus 5 over m plus 6 divided by m plus 6 times 3m plus 1, well, luckily this dude is already factored for us, so there's not a whole lot of factoring that needs to happen. So I can honestly, hopefully it's obvious that the m plus 6's are going to cancel, but let's talk excluded values first. Well, what can't m be? Remember, in a fraction, 0 cannot happen in the denominator, in the bottom. So in order to find out where these things equal 0, what you could do is you could say, all right, well, m plus 6 cannot equal 0, and 3m plus 1 cannot equal 0. And that will give you what your excluded values are going to be. So if you want to, once again, go ahead and pause and see if you can figure these out. Shouldn't take you that long. Give you guys a second. Hopefully it's not too much of a reach to say that m couldn't equal -6 and -1/3. So let's go ahead and cancel what we are meant to cancel. And what we have as the reduction of this fraction is 2m minus 5 over 3m plus 1. And that's it. And as long as your excluded values are included in the answer, these both here are going to be what's required of you. Okay, so let's go ahead and take a look at another example here. All right, so in your textbooks, this is number 11-5. If you look at A, it gives you x squared plus 6x plus 9 over x squared minus 9. And they're asking us to simplify this fraction. Well, from here, the first thing I'm going to do, it's not like the previous example, right? Like the previous example was already factored for us. We're going to be in charge of factoring that. So we're going to have to bust out some of our old integrated 2 skills. Now, if you need the area model, feel free to use the area model. These factors are pretty straightforward, at least I think so. So we can go ahead and just call this dude x plus 3 times x minus 3 all over x plus 3 times x minus 3. And I do realize that should be x plus 3 times x plus 3. Sorry about that. So the top was factored almost incorrectly, but now we've got it all taken care of. Okay, so let's talk about what x cannot be here. So let's talk about some excluded values here. Let's talk excluded values. Again, for my excluded values, I only look at the bottom. So what can't x become? I feel like if x was plus or minus 3, we'd be in trouble. So let's go ahead and not let it be that. After we have identified those excluded values, let's cancel what we are meant to cancel, and I end up with x plus 3 over x minus 3. Oops, did not mean to put that equal sign there. Don't put that there. And there you go. There is your problem when it is factored and canceled and simplified and stated with the excluded values. Let's try another one here. Let's try one last one. So a little more difficult here. So 2x squared minus x minus 10 over 3x squared plus 7x plus 2. Okay, so a little bit heavier on the factoring. Let's go ahead and do it. So I'm going to go ahead and draw my bubbles up top and bottom. And again, if you need to use the area model, go ahead and use that area model. I will go ahead and factor this quickly. I think I'm going to go ahead and put the 2 right here and the 5 right here. I'm going to go and check my values here. If I multiply these guys together, I get a 4. If I multiply these guys together, I get a 5. That can definitely become a -1. And that would be true if the 4 was positive and the 5 was negative. So then 3x and x. I'm going to go out on a limb here and put a 2 here and a 1 here. Again, because if I multiply the 3 and the 2, I get a 6. A 1 and the x gets a 7. And there you go. Now, let's talk reasonable expectation. I feel like this problem wants me to cancel something. I feel like a plus needs to go there for the sake of canceling out the 2's. And then a plus will definitely go there because the last guy's positive. Okay, so from here, let's talk excluded values. You might be ahead of me. If you are, great job. X cannot equal negative 1/3 and negative 2. And now we're going to cancel out our commonalities. And so I've got 2x minus 5 over 3x plus 1. And that is my answer for B. Okay, so I am hoping that will clarify this lesson for all of you. As always, please leave comments or questions in the comments area if you have any questions, and I will see you all in the next episode.